So welcome back to my channel. So in this video, I will cover the basics of the quadratic functions. So in order to understand what's the quadratic functions, so let's see the following situation. So let's imagine you are playing the soccer ball and you want to kick this ball into this position. So you'll notice that the ball will undergo this motion right here, and the shape of this motion is called the parabola shape. So this shape has certain properties. So the ball will undergo this motion and it will stay at the maximum point, and eventually it will drop at the original position, and it's the ground position. So basically, what is the name of this shape? So this name of this shape is parabola shape, and the properties we have a nonlinear properties. So it contains one highest point and also one minimum point. So the ball will drop and eventually lands in the same position. So this is the properties of the parabola shape. So next I will provide you a definition of quadratic function. So here's a definition. The polynomial expression with degrees of 2 equals to fx is a quadratic function. So what does that mean? The degree 2 polynomial expression. So it means that the highest exponent in the polynomial function is 2. So we call this degree 2 function. So let's look for the following. So we need to figure out, are these quadratic functions? So the first one, x squared plus 2x plus 3. So for this expression, we could see that the highest exponent is equal to 2. So I can say that this is quadratic function because the highest exponent here is equal to 2. What about next one? Fx equals x plus 2. So you learned that in Math 10, this one is the linear function and it's degree 1. So cannot capture this one as a quadratic function. So what about the next one? X cubed plus 2x squared minus 1. So you see that the highest exponent in this polynomial function is cubed, is 3. So we cannot say this is degree 2 function. So for the last one, we have x squared plus x 1 over 2. So for this one, the highest exponent is 2 here, but we cannot say this one is a quadratic function. So why? Because we have the square root here, x 1 over 2, we have the fraction exponent, so we cannot account this one as a polynomial, so we cannot account this one as a quadratic function. So the only quadratic function in this example is x squared plus 2x plus 3. So the other three are not quadratic functions. So next I will provide you the basic form of quadratic function. So we have y equals x squared. So the reason why this one is the quadratic function because the high exponent is equal to 2 in this expression. And for today's video, I'm going to give a rough sketch of this y equals x squared. So I'm going to provide you some values, x values here, and you are going to plug in these x values to the function here and generate the y values. So we have these values here, -3 to 3, and I'm going to plug in these values into x here and to generate the y values. So the first one, I'm going to plug in the -3 into the quadratic function here. So if I plug in -3 to the quadratic function, I got -3 squared equals to +9. So -2 squared equals to 4. -1 squared equals to 1. And 0 squared equals to 0. 1 squared equals to 1. 2 squared equals to 4. And 3 squared equals to 9. So I have this point here with x and y, and I'm going to plug in these values into the function right here. So this is my rough sketch of y equals x squared. So we have the first point at this position, -3, 9, and the second point here, -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. So this is my rough sketch of the y equals x squared. So next, what are the basic properties of this quadratic function? So we found that the function drops at the beginning and it starts to increase at x equals 0. And we also found that we have the minimum value at x equals 0. So when x equals 0, the function value is 0. So we found that the minimum value is 0 and the vertex is at 0, 0. So and also we found that this function here is symmetric. So if we use this line for our reference line, y-axis, we found that this is actually a symmetric diagram. if we use this one as my axis of symmetry. So at this point, the axis of symmetry is x equals 0. And what about the domain and range for this function? So we know that the domain is all x values, and the range is y greater or equals to 0. So this is all the basic properties of the basic function y equals x squared. So for the next video, I will introduce how the constant will affect the quadratic function. So see you later.